So good morning, good day, or good evening from wherever you might be joining us, and welcome to this Kalmar webinar. Today we'll be talking about designing future-proof container terminals. My name is Jenni Laine. I work in marketing at Kalmar, and I will be your facilitator today. But first, let's go through some practicalities. During the presentation, all participants are automatically muted. And when you have questions, please send them to the control panel questions window at any time of the presentation. In the end, you will also be given extra time to add your questions there. And the webinar material will be supplied to you at the end, so if you experience any network issues or technical breaks, the webinar recording will be sent to all of you afterwards later this week. But without further ado, I think we are ready to dive into today's topic and discover what our terminal design services experts have prepared for us. So Timo and Jarno, welcome. The floor is yours.
Okay, thank you, Jenni, and welcome everyone from my behalf. So my name is Timo Alho, and I am from Kalmar Tampere office, so from Finland. I have worked at Cargotec for almost 20 years. First in automation R&D, where my key project was the development of Kalmar AutoStrad solution. And during past years, I have been involved in practically almost all Kalmar terminal automation projects in various roles, from product management into to the head of the cranes business line. And currently, I'm one member of this Kalmar Terminal Design Services team.
Well, my name is Jarno Kuipers, and I also welcome you to this webinar. I am from Rotterdam in the Netherlands, and I started my career in IT consultancy and then shifted to the port. And I've been working in an automated terminal for many years before joining Kalmar. And now already over 8 years in Kalmar, did several sales roles, execution roles, and now working together with Timo and some other colleagues in the terminal design services. So again, welcome. We like to present now the agenda of what we are going to discuss today. First, the introduction into, let's say, the title of the presentation, what is a future-proof terminal? Then we have 3 examples of, let's say, terminal design services topics that we selected and that might be interesting for you. First, selecting the right auto RCG setup. Then the second is the Kalmar full electric fast charge and the business case of this fast charge solution. Then third, simulation example, how we identified optimization opportunities. And then we will close with and walk you through the terminal design process, how we do that at Kalmar. And then finally, like Jenni already announced, we will do the questions and answers. And again, if you have questions, please post them in the chat window. Okay, so let's go to the introduction into the topic. This topic for today, future-proof terminal. So what is a future-proof terminal? We have identified 4 areas where we think it's very important to have those covered. So terminals need to be efficient. That's like, okay, the sort of the starting point, productive, low handling cost per unit. But it's also very important that it's not only okay for, let's say, today, it needs to be flexible and scalable and adapt to any change in your business environment. And then nowadays, there's a lot of pressure to be eco-efficient. So yeah, it's quite wise to also cover, let's say, that area. And last but certainly not least, terminal needs to be safe, and everybody needs to return at the end of the day home safely. And I think one of the challenges nowadays is how do you apply these items to a brownfield terminal, because there's not that many greenfield terminals left. So most of the projects really concern brownfield terminals. and then how to combine all these 4 elements into a specific solution that really matches your needs. That's the challenge, and it needs hard work and some analyzing and studying. But okay, that's what you need to do, and what we also can do for you. Okay, the first topic, selecting the right auto RTG setup. So first, starting with what is now the attraction of the auto RTG? Well, as a starter, the RTG itself is the most popular container yard crane. Approximately 2/3 of all yard cranes are rubber tired gantry cranes. And then nowadays we have the option to automate these cranes. And the reasons, let's say, or why is it so, let's say, attractive to automate the auto RTG or the RTG? First of all, there's less time lost because there's no transportation time to and from the crane for the operator during shift changes and meal breaks. And second, you can operate multiple RTGs with one operator. It's possible also to automate step by step, not going directly to full automation. It's also possible to retrofit your existing cranes and even do, let's say, implement everything like gradually, block by block. Also, the outlook to a fully automated terminal is there, although it would need an automated terminal tractor that is suited for a mixed traffic environment. But well, everybody expects that that product will become available in the near future. There's many tests ongoing. And then, well, also just getting the operator out of the cabin, it increases the safety and also increases the ergonomics for the operators. But then, okay, the right setup of this auto RTG, what does it basically consist of? Well, there's like 3 elements that need to be considered when picking the right solution. First of all, there's the electrification and the data connection. There's the automation level, and there's especially in brownfield terminals, there's the infrastructure that's currently there and how to deploy it in your operational terminal. And it is always good to realize that the choices you make in each of these segments or areas will influence each other and will impact on the total solution. So first, stepping into the electrification. Well, there's many advantages in electrifying your RTGs. Economically, it reduces the maintenance effort and cost. Of course, it saves diesel because it only uses electricity, which is typically cheaper, and it saves time and cost for refueling stops. So this in total creates quite nice returns on investment, relatively fast payback times. But of course, on top of all the economical advantages, there's also the environmental advantages. There's no CO2 footprint, and also the let's say the local emissions of the pollution, the gas pollution, is not there. And a really nice thing is also that the cranes are produce much less noise, so that's also good for the environment, and especially if you have people living close by. So if we switch then to this impact of the electrification on the design, then I think it's good to walk you through, let's say, different solutions for electrification. The first one, hybrid solution. Well, it's let's say it's not really full electrification, but it saves diesel and is more efficient. And the big advantage is that you keep all the advantage of the current, let's say, diesel RTG. So it's easy to change the block between one stack block and the other. not really much infrastructure needed, and you can work with as many RTGs in let's say a single block as you can fit. Of course, there's also some cons. The wireless technology needed really for the automation is still young, although we had very nice results in our R&D test backyard in Tampere. We also know that this technology has not proven itself, let's say, on a big scale. So outlook is very good, but unfortunately not proven yet. Then of course you still consume diesel as well and have some emissions, and because you keep also the generator, there's still some higher maintenance cost. But it's a nice step, maybe in between, and keeping the flexibility. Then when we move to the other two solutions, they are real, full electrification solutions. No emissions. And cable reel is especially a proven solution when it comes to the data transmission, the speeds, the latency, the reliability. Well, also, let's say there's a maintenance reduction. You lose the generator. The cons, especially in your existing layout, you might require some additional space to put the cable on the ground, which might force you to let's say go to the back-to-back setup, which basically means that the cable reels of the two RTGs are facing each other, and there's no trucks in that sort of corridor, but the trucks will be on the other side, usually sharing the passing lane. Block changes with the cable reel solution are possible, but it's a little bit less flexible than the next one, the bus bar, because you always have to wind up the cable reel before disconnecting it. And okay, both solutions have typically a maximum number of RTGs that you can fit in the block because of the connections and the power supply. Busbar solution, easier to change the blocks. Also full electric solution with the maintenance reduction. The con, busbar structures are needed along every block, and also they require additional space. And yes, so also maximum amount of RTGs in the block. So maybe we can go to the next slide. Yes, so next topic, the impact of the automation on your layout. If you look at the picture on the right side, you see from left to right different levels of automation, starting with the remote control, going to supervised moves where the operator is still responsible for the safety, going to automated pick and place in the stack, adding the automated gantry movements, and then going to a fully automated situation. Well, depending on let's say the level, there are also impacts. There might be impacts at least on the layout. So the impact of the electrification we already discussed in the previous slide, and then additionally for the automated pick and place, if you're depending a little bit on the ground slope, you might need bigger container gaps to allow the crane to reliably pick up the containers. When also for the automated pick and place in the stack, to prevent truck drivers from entering the yard and well, walking under a container, it's good to have like a fence between the truck lane and the yard. And then additionally also when we talk about automated gantry, to be able to scan for obstacles reliably, that it's good that the truck lane is wide enough and to allow those safe automated gantry moves. So going to the next let's say third sort of element in this whole setup is the infrastructure and how you intend to deploy it into your, well, mostly operating terminal. First, let's say there are all kinds of infrastructure elements that terminals have. And one example is the RTG drive pads. So if you have those, then of course, if you would need to change your configuration, it would create cost to well, move them or at least make some additional. Similar with reefer racks and container plinth foundations. Then, well, as discussed also with electrification, if you need to change to a back-to-back setup with a shared passing lane, it might have consequences, creating cable reel connections, making sure light masts are in the correct positions, adding substations for electrification, and then, okay, how do you want to deploy, let's say, this automation to your yard, starting with what area first, etc. It really needs careful study, and well, we have seen in projects we've done with customers that it's not always easy to implement the level that the customer wants in terms of, let's say, electrification and also in terms of automation. So the big question is, okay, do you have the space available to implement what you want? So now I like to give the, let's say, the turn to Timo, which will tell you something about the Kalmar Fast Charge business case.
Okay, thank you very much, Jarno. So in our next example, I am walking you through a business case that is related to Kalmar Fast Charge technology with the shuttle carriers and straddle carriers, and we are taking here an aspect of CO2 taxation and the impact of these taxation levels into the business case of fast charge. And this fast charge technology, overall, it's a technology that that makes the Kalmar straddle carriers and shuttle carriers as fully electrically powered using the lithium-ion battery technology. And the system comes with an efficient charging system as well that can recharge the battery within very short time frame when activated. But let's start from the current state where this carbon taxation setup currently is. So the whole carbon taxation is now implemented in 57 different countries, and there are pricing of these initiatives is varying a lot. So if we start from in this picture that is illustrating different countries who have been adopting the carbon taxation, the top one at the top of the screen is Sweden, who have currently carbon taxation around 127 US dollars per each ton of CO2 emitted. Then if we go down, typically, well, let's say we see the range of from 40 US dollars to 80 US dollars, and that is actually the range where many of the researchers are saying that the carbon taxation should be in order to reach the Paris Agreement temperature target levels. But at the moment, the most of the countries who have been adopting the carbon taxation in their legislation are actually on the lower segment, so varying from 0 to 25 US dollars per CO2 ton. So for the next business case, we have been splitting this now into 3 different categories. The top end, the level of Sweden, 127 USD. Then the middle level, which is the Paris Agreement level, and then the lower end, number 3. And over here we can see a map of the development of this carbon taxation during the last years. So on the left, how the situation was in 2014, and on the right, again, situation at the current date. So you can see that there are certain changes that have been happening during these years, and the main changes are actually that first of all, the biggest, China, has been implementing the emission trading system during these 5 years. Also, most parts of the Canada, both emission trading system and some carbon tax has been implemented. And then several other countries like Ukraine, Poland, Spain, Colombia, Chile, Argentina have also been implementing the carbon tax. Also, some other countries during these 5 years have been starting to take the carbon taxation or emission trading system under consideration. For example, Vietnam and some countries in Western Africa. But the big thing is here. So in 2014, actually, about 12% of the global emissions of the greenhouse gases were under some legislation of carbon taxation. But already in 2019, that percent was 20%. So that means that actually 20% of all greenhouse gases that are emitted globally are now covered with the carbon taxation, and that goes through 46 national and 28 subnational jurisdictions. And we can only imagine that what the situation in 2024 will look like. Maybe we are talking about 30 or 35%. And as earlier said, in order to really reach the temperature target in the Paris Agreement, the carbon taxation levels of about 40 to 80 US dollars per ton of CO2 should be implemented already by 2020 within the countries that have signed the agreement. So overall, the awareness of these things is really increasing, and so is the coverage of the greenhouse gases, and also the pricing of these carbon taxation initiatives is growing really fast. So then looking at the straddle carriers and shuttle carriers and the fast charge technology. So the first full-scale deployments of this technology are currently being delivered, and in the market the market is really waiting for references which will be there within next 1 to 2 years. And as mentioned on earlier slides, the increasing CO2 taxation initiatives are there. So they are clearly increasing the financial feasibility of this solution, despite the fact that there is higher capex cost to implement this technology. So you need the charging stations and the higher battery capacity and that kind of things, which will cost as an investment in the beginning. And the drivers overall of the electrification in port operations, of course, they are the savings in operational costs. So both the maintenance cost and also the energy costs related to operating these machines. And also this increase in carbon taxation is contributing to the business cases. So energy efficient or eco-efficient initiatives are becoming more and more attractive. But also the sustainability is seen as one of the core values that especially the customers and customers are demanding for lower carbon footprint in the whole logistic chain. And lastly, also there are several government incentives in various countries for investments in green technologies. So now we look at the business case. We have been comparing 3 different cases. So a fleet of 8 automated shuttle carriers, and their difference is that in the first case they are fully diesel electric. In the second case they are diesel hybrid, and in the third case they are a fleet of fully electric fast charge shuttle carriers. And the last business case includes also the investment cost into the 2 charging stations and also the related field cabling to supply these charging stations. And there are some other inputs in this business case that we've been using. So first of all, the factor to convert the liter of diesel consumed into carbon dioxide which is, I think, quite a well-known factor. Diesel price, we have been now using €1 per liter. Electricity price, 10 cents per kilowatt hour. The annual operating hours per each of these 8 machines is 5,000 hours. And we are not in this business case taking into account any annual increases for energy prices, not for fuel and not for electricity. And lastly, the operation is automated operation, so the labor cost of drivers is not included in this study. So over here we are seeing then the results of the calculations. So we can see the 3 different cases as I described earlier. We have on the left the business case in case the carbon taxation is in the lowest level of around $10 per CO2 ton. In the middle one, the carbon taxation is within US $60, and that is the Paris Agreement target level. And then on the right hand side we have the top end, so $127 per CO2 ton. And in these lines here represent the fast charge cumulative investment compared to a fleet of diesel electric or fleet of hybrid. So the graphs are starting from the negative side because obviously with the fast charge there is a higher initial investment into this technology, the charging stations and the batteries and so on. But as the time goes on, both graphs are rising up, so that means that the lower operating costs are causing the solution to become more attractive. And the point where the graphs are crossing the 0 level line, that means that the cumulative cost of fast charge investment and operation compared to a reference case, diesel electric or hybrid, is the same. And from that point onwards towards the right, the fast charge technology will cost itself back because of the lower operating costs. And on the down, the table in the bottom of this page, we can see then the same in figures. So compared to hybrid shuttle carriers, there is about 5.4 years payback if the carbon taxation is on the lowest level, while if it would be increasing up to US $127, it would be 3.9 years anymore. So there's a 1.5 years difference. And compared to diesel electric, we can see that the figures are almost the same. However, it must be reminded that as we can see, the angle how the operating costs are actually developing for diesel electric, the operating costs will be within the 15 years lifetime of the equipment significantly higher than for hybrid. So now it is time for our first poll question. So this is related to the CO2 footprint, and we are asking from you what kind of pressures does your terminal have in terms of reduction of CO2 footprint and emissions. And we are asking you to choose from one of the 5 options below. So first of all, first option is if eco-efficiency also means makes sense if it means cost savings at the same time. Second option is that there are potential regulations by authorities. Third one is the demand from your customers for a lower carbon footprint and emissions. And the fourth one, the overall green image. And the last one is that you don't have a pressure at all to reduce the CO2 footprint. So please, we will give you some time to respond to this question. Okay, looks like we are getting some responses. So about half of the people who are attending have been now responding. Okay, maybe we will look at what kind of results we have. So yeah, it looks like 33% of you have been saying that you expect some regulations by authorities that will also cover your terminal, and then you see also the overall green image to be important, but also 25% are seeing that whenever if there is also cost savings involved, then you are interested. Thank you very much for this input. Then we continue to our next topic. So it is related to terminal simulations, and over here I'm presenting one of our customer cases. So this is over here we are talking about an existing customer who has been operating a straddle carrier terminal for 15 years now. And when the terminal was originally starting the operation, the traffic flow was very common between more or less 100% of the containers were transported between quayside and trucks. So typical import-export type of a terminal. However, time has been going forward, and the business environment of this terminal has been changing significantly. So during those years, many of the factories within the area have been actually moving the warehouses to the port area, and nowadays main container flow is actually inside the container terminal. So empty containers are received on the quayside. They are transported to empty depot, then to the warehouses where they are getting stuffed, and then again back to export yard and the quay. So only about 20-25% of the container flows currently are between the quayside and truck, where the terminal was originally designed for. And of course, this means that the layout that was adopted at that time is not probably anymore the best for this purpose. So this terminal management is interested in studying the alternative terminal layouts to resolve some of the pain points in this terminal, but also investigate some new technology that they could use for optimizing the current deployment of straddle carriers better within this terminal, and that would really mean to move one common equipment pool instead of dedicated pools for each ship-to-shore crane. And of course, this kind of things cannot be really studied by introducing a trial in a live terminal operation. So simulation is a really good tool to assess this kind of changes. So in the first step of this study, we developed the two alternative layout options for the terminal. Both of them were seen by both Kalmar people and also the terminal management that they would resolve the critical pain points and the issues within the current layout. And for simulation input, we gathered 2 weeks operational data from the terminal's TOS system, and that was corresponding about 30,000 straddle carrier moves throughout that period. And that data was used as an input for this simulation, so operating the virtual model of the container terminal. And the same operation, including the job assignments and decking logic, it was executed in the simulation model with the current layout as it is built now, and then with the two alternative layouts to see the difference of the travel distances within the different layouts. And the received data from a simulation was then categorized also based on the different move types, so that we could really assess the benefits in which area we are getting the improvements and which areas we are getting to the worse direction. And in the table below, you can see some results. So we have been separating the laden distances of the straddle carrier traveling and also unladen distances of straddle carriers, and then combining them to the total distance traveled. And when comparing the current layout into the layout option 1 that we introduced, we saw that there was about 9% improvement in the travel distances. So overall, the total travel distance traveled by the straddle carriers was decreasing 9%. And that would actually mean in practice the difference about 5,000 kilometers within 2 weeks time. Then layout option 2, there was actually, the result was a little bit surprising. So the distances were actually increasing about the same amount. So for 5,000 kilometers. And this was a little bit surprising because before carrying out the simulation, actually the whole team thought that also the layout option number 2 will significantly improve the situation. But as we can see, simulation is showing a different result. Over here we have been still categorizing them a little bit in more detail. So we split the total travel distances into the moves related to STS. So picking or grounding under the STS. Second category is the yard moves. So containers departing or ending to the container yard. Then the truck moves, warehouse moves, and other container moves done within this terminal. And over here we can see that there's a clear improvement with the layout number 1 with the STS moves and also the yard moves, while the other areas are not impacted that much. And but the layout number 2 also yard moves, we got some improvement, but actually the STS moves and the warehouse moves got much worse. So that was then causing the big difference, and the layout number 2 being the worse than the other one. In the other part of this terminal study, so step number 2, we carried out an assessment that for this terminal, that if they would change the methodology how they are assigning the works to the straddle carriers, so instead of having one dedicated, instead of having dedicated driver pools for each STS, they would operate all strads in the same one big pool, and then assign the best job for each straddle carrier. And how we did it was that in the simulation, every time a new job was assigned to the straddle carrier, there was an evaluation made that would there be another alternative job available for this straddle carrier that would be within the 15 minutes time window with a shorter distance to travel to the picking location of the container. And if we found a better job, then the job was recorded into a database, and we marked that job as a used job, so we wouldn't use it the second time again. And this way we were gaining an estimate of the saving potential for unladen travel distances within this terminal. And the results are then represented in the graph on the right. So as we can see that the unladen travel distance is actually reducing from 32,000 kilometers into about 11,000 kilometers. So based on this study, there's a huge saving potential just to optimize better the job assignment within this terminal. So this is another typical example of what you actually can gain with the simulation without really hassling anything in the live operation, but just triangulating in the virtual world. So now I'm handing the control back to Jarno, who will walk you throughout the rest of our presentation.
Okay, thank you, Timo. Well, as the final topic before the questions and answer, we like to walk you through our Terminal Design Pro. And the first, let's say, sheet that is now currently on the screen, it shows the whole process from design until operation. And the current, let's say, currently what we're talking about currently is let's say the first row. So this really shows that there's many more steps to take until you're fully operational. And what this sheet also shows you that any changes that you need to make, let's say later in the process, because well, there's changes in circumstances, or you made a mistake, or let's say any change is typically more expensive at a later stage than it is at in this, let's say, design stage. And that's why it's really important to spend enough time on the planning phase. So I think that's the message of this sheet. And what do we now, if we do a design process, let's say our commercial representation is typically, okay, we have 3 phases. The investigation phase, where we create the, let's say, different options, and we try to qualify these options, and when we like the results of any of these options, we try to demonstrate them. When we look a little bit more, let's say, close in each of these phases, then okay, in the first phase, typically there's multiple options that we create, and we have to say we always create it together with the customer. So it's really like a co-creation, because we know, and we've experienced that you are much more let's say knowledgeable about your own situation than we are, and it's really, you know, the result of good cooperation where we create good designs. So okay, this first phase we create the designs, and then in the next phase we try to qualify these designs in terms of operations and in terms of business case, and these are all like static analyses, and sometimes we need to iterate still with the previous phase, and also maybe change it according to, well, let's say, your feedback. And then the best ones we typically take into this demonstration phase, where we really validate, let's say, how, if the model works properly, and this validation is done by simulations, and that's like really dynamic, and we can check many more things, create different scenarios, test, let's say, different sensitivities with you, and really get a good feeling how it would work in different situations. Of course, also the benefit is that you typically get a very nice view on the 3D model, how it would work, and which can be used also for marketing purposes. So some problems and challenges we have, let's say, noted and seen. I think, well, one of the first and most important is the business case comprehensiveness. So only comparing equipment apples to apples is, well, actually it's not really apples to apples, because each type of equipment has a different impact on the infrastructure and the IT cost. So really making sure that the business case comprehensive is important. Another, let's say, issue we've seen, that really the risk and the scenario comprehensiveness. So if you only plan for, let's say, one scenario, one future, you also know, well, that this design will be only optimized for that one scenario. So again, testing enough scenarios for different possible futures is quite important. We've also seen that it's very difficult to involve all the required skills throughout the project, whether it's equipment, operations, IT, infrastructure. I think there's a lot of, let's say, checks and balances throughout the process. Okay, along the way, sometimes there are refinement needed, or let's say additional information becomes available, and then let's say a lot of times people don't go back and really check what this means for the design and the calculations and the simulations. And in general, okay, people think that they have a lot of time for making the design, but typically we experience that there's more time needed than let's say estimated before they start. People start, and well, it's just hard work and a lot of iterations which take time, and typically the value is in the last steps. which you don't want to skip. So what we see in practice that if, let's say, these issues occur, often there's like a focus on one operational concept, which sometimes lacks the solid checks and of sensitivities and alternatives. So to summarize, okay, there's many opportunities to increase your automation level and also your eco-efficiency. Brownfield terminals, really the conversion needs careful planning. Simulation is a really excellent, and although you need to spend some money on it, but it's really the cheapest way to verify the assumptions, much better than in real life, and to make changes in real life. So if you need any support, please do not hesitate to reach out to us. Okay, before we go to the questions and answer, we like to do another poll. What kind of measurements do you intend to take to make your terminal future-proof? First one, optimizing current operations. Second, electrifying or automating existing equipment. Third, investing in new eco-efficient equipment. Fourth, investing in new automated equipment. And last, well, you don't have any plans to make any changes. Well, the reactions are coming in. %. If you like to still join, please press one of the options. Okay, maybe we should see what the results are. Okay. So, most popular, investing in new automated equipment. Electrifying is popular. Well, at least all of you who have responded are planning at least something. So, okay. Then I think we're ready for the questions and answers. And I'd like to give the word to Jenny.
Okay, thank you very much, and welcome to the Q&A part. There's still time to post your questions using the control panel window, so be brave, ask now. But we have a couple of questions here already, so let's start with something. First question is about auto RTG. So how many RTGs can one operator control? Jarno, would that be for you?
Oh yes, let's. Okay, how many RTGs can one operator control? Well, typically the ratio between the RTG, the operators, and the number of RTGs depends on the specific operational situation and on the automation level. By placing the operator behind a remote desk in the office, of course, he has the possibility to connect and control any RTG, and that makes it possible to only connect to the RTG when to a specific RTG when needed. And well, typical, even in busy times, we see that RTGs idle at least 30%. So even in busy times, you could save that amount by only going to remote control, not even automating. And with higher automation levels, let's say the reduction can even be bigger. And also what you have to remember is that when there's, let's say, not so busy times, you can really operate a lot of cranes with one operator. So it also creates possibilities to extend your opening hours with let's say limited resources.
Thank you. Okay, here's a two-part question. How long does the fast charge battery last? And the maximum time between charges in a typical operation. It's about fast charge, so would you like to take that, Jarno? Or
Yeah, sure. So the maximum time between charging and the typical operation. Yeah, of course, the question is always what is typical. Typical depends a little bit on let's say, well, maybe to first explain, most of the energy consumption is consumed by traveling with the straddle carrier or the shuttle carrier, in addition to some other factors, but that's the main factor. So if you do a lot of long distance traveling, then the consumption is a bit higher. But we have seen that with let's say, traveling between the stack and the STS cranes, that typically you can last for 50 minutes on one charge, and well, then you need to charge for a couple of minutes again. So
good. And I think we continue with fast charge. Still one more question. Can fast charge be retrofitted to other straddle carriers?
well, yes, they can be retrofitted, let's say, but it depends a little bit on the model. When we take our hybrid straddle carriers, they basically have the same design, and they have a battery, but it's a small battery, and instead of the generator on the hybrid, we would remove the generator and place there a bigger battery, and of course we need to retrofit the connection points for charging, but basically there would not be that much, let's say, from a technical point, that much difference. So yes, it's possible, but well, not with the old ones, but the hybrids are able to retrofit.
Okay. Then there's a question about the design process. So typically, how much time would the high-level design and detailed design stages take? Timo?
Okay, I think that's a great question. So this really varies a lot on the project by project. So some projects are really going forward very rapidly when there's a strong drive forward to go to the implementation, while the other projects they might stay in the high level design for years and years, studying different business case options and so on. So it's really difficult to say like a one figure here, but I would say that maybe the high level design, you could say that it takes maybe half a year, 1 year, something like that, and then the detailed design of a terminal another year.
Good. And then I think maybe the final question here, looking at auto RTGs, since which generation of RTG can be upgraded to auto RTG? Example, one RTG from 2009, can that be upgraded to auto RTG?
Okay, so maybe I can take also this question. Yeah, I think it depends on a little bit the automation level that is targeted here. So there are certain features of the RTGs, like for example anti-sway systems and so on, that will impact what is the level that you actually can fit into this RTG. And then the other aspect is that how much lifetime the RTG really still have left. I mean that do you still want to really invest into this RTG much if it has, for example, 5 years time left. Now the question is about RTG from 2009. So I believe that in some level of automation it can be retrofitted, like talking about this remote control and supervised automation for sure. The higher level of automation would need to be really investigated closer by seeing the machine specification.
Thank you, Timo. Really good questions here. But now I'm receiving signal that our time is up. So we're going to say thank you very much to everyone. It was a pleasure to have you all here, and super thanks to Timo and Jarno for hosting this webinar. And as mentioned, I will send you the recording of this webinar and also some additional materials. And if you have any additional questions, you can always contact our team members and also post them to these addresses you can see on the slide. I would like to wish you a nice rest of the day and all the best to your business and end of the year. So thank you very much.